Good day, everybody. How are you all? Today, we are going to talk about a problem on linear regression. So, I'll share my computer screen with you. A researcher wants to know if the age of a child is related to the number of cavities that he or she has. The data are shown here. Age of the child is X or independent variable. Number of cavities is Y or dependent variable. And there were several parts of the problem. First, so in order to do this problem, first thing we'll press is second button, then plus button on top of the enter button on the bottom right corner of the calculator key, and then select number 4. So we will get clear all list, and then we press the enter button and get done. That means memories of TI-84 have been cleared. Then we will press Start button and select number 1, which is edit. Okay, then enter X data in L1 and enter Y data in L2. So let's do that. Second button, then plus on top of enter, then number 4, clear all list, hit enter, done, then start, then number 1, edit, enter X data in L1, Y data in L2. So we will start with the X data. 6, then 8, then 9, then 10, then 12, then 14. And then I'll press the right cursor key to move the cursor to the first line in L2, and then 2, 1, 3, 4, 6, 5 in L2. So we have the X and Y data. If we want to see the scatter plot, let me create some space over here. Okay, so we'll do zoom 9. Okay, so do a scatter plot. Between X and Y. Press zoom key, which is the third key in the top row, extreme top row, and then press 9, zoom 9. And the scatter plot that I see on my calculator screen is like this. So there is one plot over here. So there is some amount of scatter in the data, and these middle lines points fall on a single line. This closely clustered. The middle data points are closely clustered around a straight line. So this is X, age of child, and this is Y, number of cavities. Okay. So we have to determine the least square regression. So again, press the Start button. Then highlight, means move the cursor on the top row to test. Okay, and then scroll down to scroll down with the down arrow key to linreg t-test. So we want to scroll down to linreg t-test. This is linear regression t-test. Hit enter. Okay. So let me create some place. Okay. So X list is already L1. X list is L1. Y list is L2. These are already there. I don't have to do anything. Okay. Frequency is 1. Set the fourth line, which is the alternate hypothesis, beta and rho, not equal to 0. And I'll explain that in a minute. But keep your cursor on the first option, beta and rho not equal to 0. Remember, this is the alternate hypothesis. Okay. And we'll talk about it in a minute, and then go down to calculate. And hit enter. The least square regression line. So the equation of the least square regression line, the least square regression line is y hat, this is the predicted y, is equal to the constant term, which is a minus 1.918 plus b value is 0.551 times x. Okay, so this is your least square regression line equation, least square regression line equation. Regression line equation. Okay. Okay. Let's move this a little bit up. Okay. So if we move a little bit up, no, move down actually. Move down with down cursor key. Cursor key. This is this key. Move down to get. First you'll get R square. R square is coefficient of determination. Coefficient of determination. Of determination. So R square in this case is 0.708. Only for R square you multiply it by 100%. And that becomes decimal moves 2 places to the right. 70.8% of the variation in Y can be explained by the least square regression model. Least square regression model. Is it a good fit? Well, we'll test it out in a minute. Okay. Now we also look at the R value. Okay. R is the correlation coefficient. Correlation coefficient. And R is 0.842, you may say. So it's a strong positive linear correlation. Linear correlation between X and Y. X and Y. Okay. Now in the last part, they had asked for S. S is also given in the calculator. This is the standard error of the measurement. And this is equal to, basically it's a standard deviation of the error is 1.129, 1.129. Okay, so that's the one part. Okay, now let's test the significance of the correlation coefficient. So let me create some space. So one part asks for test the correlation, test the significance of the correlation coefficient. Coefficient. Okay. So, what happened? Now, let me see. What happened? So, and they disappeared. Oh, here it is. Look at that. So we will blow it up. Okay. Okay. Test the significance of the correlation coefficient. That's what we were working with. Okay. So our null hypothesis is rho equal to 0. That means population correlation coefficient. Correlation coefficient. That's why I'll explain in a moment. Population correlation coefficient is rho, to be read as rho, Greek R, is equal to 0. That means we assume in the population, there is no correlation between X and Y. Correlation between X and Y. Between X and Y. Okay. And our alternate, remember I told you to select the fourth line as the alternate as rho not equal to 0. Okay. So it is opposite of the null hypothesis. Okay. And now let's look at the test statistic. So if I move up, okay, and I will move up here too. The test statistic. So the test statistic is T, and that is equal to 3.1177. And look at the corresponding p-value. So p-value is equal to 0.0356. Okay. So this is the probability of getting a test statistic as extreme as 3.1177 or more extreme. Okay. What does this mean? Test statistic. That means the sample correlation coefficient R is 3.1177 times standard error above the population hypothesized slope. Okay. Now our given alpha value, alpha was given as 0.05. This was given in the problem statement. So compare P with alpha. P is greater than, sorry, my mistake. P is less than alpha because P is 0.0356, alpha is 0.05. So P is less than alpha. Decision, reject 80. Conclusion, at alpha equal to 0.05, there is enough evidence to support HA, which states rho not equal to 0. That means in the population, most probably there is a correlation between X and Y. Because we rejected the null hypothesis and we supported the alternate, which is rho not equal to 0. Okay, that means in the population there is most probably a correlation between X and Y. Now there is another part to this problem, and I'll create some space here. Okay. So it was last part. Predict Y hat for X is equal to 10. Now the least square regression line equation is Y hat equal to minus 1.918 plus 0.551 times X. So 0.551 is actually the slope of the regression line. That means when X changes by 1 unit, Y will increase by 0.55 units. Now we have been asked to predict Y hat for X is equal to 10. Now let me show you something. Let's take a look at the data. Look, the lowest value of X is 6 and the highest value is 14. So X is equal to 10 is inside the range. And the actual value of Y at X is equal to 10 is 4. Okay. So with this information, let's go and predict the value of Y using the least square regression line. Okay. So let me put this. Okay. So then Y hat will be equal to minus 1.918 plus 0.551 times 10. Okay. How do you do it in your calculator? Well, First, you type in the negative sign. The negative sign is next to enter. Minus 1.918 plus 0.551 times 10. And the predicted y hat is 3.592. It's 3.592. Now, from the given data, y actual for x is equal to 10 is 4. Okay. So the residual for x is equal to 10 is y actual minus y hat, which is 4 minus 3.592. And that residual is 4 minus 3.592 is 0.408. So this is your residual at x equal to 10, which is y actual minus y predicted, or the error term. Residual is same as error. Okay. So I will stop here today. If you have any question or comment, write me a note. I'll get back to you as soon as possible. And if you like this video, please give me a thumbs up. You can share this video with your friend if you like it. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner of the screen. And I will see you next time with another interesting problem, interesting solution. Take care. Have a nice day. See you next time.